All right, so here we are in the lab again, and this episode is about the components of MainBrain. And so, but before we get started, I want to show you MainBrain in action because I've been working on the motion board, and it's a milestone in the project because I'm able to run, take short sequences of motion, put them together, and I can either run just a single time, or in this instance, I'm just looping it through over and over again. So yeah, check it out. Okay, so here we have MainBrain, and we're going to go over the components that make up MainBrain. And so let's start with the I/O connector right here. This is where it connects all the peripherals. So the peripherals connect through the connector into the SRAM, and then the microcontroller that's on the other side reads and writes to this SRAM and sends commands to the peripherals through the SRAM and gets status back from the peripherals through the SRAM. Alright, and then the I/O connector is the only part on the board that we have to solder in the oven because there's 2 rows of pins, 68 total, and the back row is all the ground, but you can't get to it with the soldering iron, so it has to be soldered in the oven. It's the only part on the board so far in the design that has to be soldered in the oven. We have the SRAM like we were talking about. This is the flash memory, 512K by 8 flash memory, and that's where the user information is stored. Anything you want to store in there, you can store in there. It's up to your program. The SRAM, 8K by 8. So then over here we have 4 through-hole components. We have the reset connector here, the ICSP connector, the power connector, and the USB connector are all through-hole for strength and longevity. And okay, so on the reset pin, the reset needs to be isolated from the ICSP when you program it. So when you program, you just pop this shunt off here. I can get it off right there like that. And then you program it. You can also connect wires here to the right here to the pins, and have a remote switch, reset switch. And then in normal operation, the shunt is on the board like that. That's normal operation. So the ICSP, that's where the code, your firmware gets put in. That is a microchip port, and that's when we use one of these guys right here, a MATLAB. There's PIC Kit 3, PIC Kit 4, PIC Kit 5, and they have one called a Snap, very affordable. The Snap I think is $35. So it has a connector like this, and then this connector goes on the MainBrain like that. I don't know if we could get that, yeah. So that's basically how you program, and then the USB plugs in right here. to your PC. And we'll go through all that, how to program it and stuff. Alright, so then over here we have the buzzer. And then over here we have the transistor that drives the buzzer. And then we have a little chip resistor over here. This guy just limits the current to the base of the transistor. And then over here we have a diode. The diode goes across the buzzer like to prevent back EMF, just like with a relay or a coil, something like that. Alright, so then we have the USB over here. That's where the PC connects, and you can transfer data back and forth, and the PC can control MainBrain. I have a Windows app for that I'm working on. Alright, and so this is the power connector here. That's where the 5 to 24 volts goes in, and it comes in, it goes through this diode right here. This is the reverse protection diode, reverse polarity protection. And then it goes through a filter made out of this inductor, and then a cap, a couple caps. And then we have some input capacitors here that works with the buck regulator. We have the buck regulator over here that takes the input voltage and regulates it to 3.3 for the board. The whole board runs on 3.3 volts. So then this is the buck regulator and SOA8 IC. Then there's some support chip caps and chip resistors around it. This is the main inductor for the buck regulator, and then this is the output capacitors for the buck regulator. And then we have a resistor, and this is a 100 milliohm resistor, and then this SOT package right here measures the voltage drop across that resistor, and then the analog to digital converter in the microcontroller reads its output and tells you what the board current is, the current usage of the board. And there's a cap and a resistor right here. The resistor works with the SOT package right here and creates a voltage divider, so you can set your output voltage of it. And then the capacitor acts as a filter, filters out some noise. Then over here we have an LED with its current limiting resistor, that when the 3.3 volts is active, it lights up so that you know that you're getting board voltage. And that's pretty much it for this side. Let's take a look at the other side here. Okay, so let's start over here. We have 8 LEDs with their current limiting resistors, and so that's the intended use of that is for debug purposes and status, and that's up to the user however they want to program them. This is the microcontroller right here. There's two oscillators. One 32.768 kilohertz for the real-time clock, and then the main oscillator for the microcontroller is 24 megahertz. There's 8 chip caps around the microcontroller for bypass caps. Let's see. Yeah, let's go over here. right here is the reset supervisor. It just holds the reset signal low until the VDD, the 3.3 volts, stabilizes for the board, and then it allows the microcontroller to boot up. And then we have two connectors here, a small one and a large one. The larger one is for, well, they're both for the display, but the larger one is the main data transfer for the display and the control. The small one is an 8-pin for the touch screen. It's an I2C bus, basically, for the touch screen. I think that's everything on here. That's a quick run-up of all the parts of MainBrain. Okay, so that was MainBrain and its components. So now we're at a stage where we talked a lot about MainBrain, so it's time to move on a little bit for a while. And I think the next thing I want to do, I need to make an I/O board for some other projects to interface with MainBrain, but I think that would be a good time. We'll just start from the beginning and build a board, design a board and have it made, and then we'll do our surface mount soldering when we put that board together. I think that'll be a good one. So the next video should be probably an introduction to Fusion 360 and drawing up the schematic and how to look up data sheets and just the general process of getting started and figuring out what we want to do. So that'll be episode 4.